Everybody loves speed internet, so it's no surprise that every major telecom in the world is working to make it even faster. Smartphones, watches, homes, and cars are increasingly requiring stable internet connections. In order to pipe in enough bandwidth for that precious wireless feed, we're going to need an entirely new form of wireless signal. That's where 5G comes in. Similar to 4G and 3G before it, 5G is a wireless connection built specifically to keep up with the proliferation of devices that need a mobile internet connection. The radio frequencies on which our 3G and 4G network operates are overcrowded. Estimates have varied over recent years, but some of the industry's established players can give us an idea where is 5G at. We have actually seen claimed speed of 7.5 Gbps from Samsung and 10 Gbps from Nokia, while University of Surrey managed to obtain a staggering 1 Tbps, the same capacity as of fiber optics, for a wireless network connection. However, all of these were conducted under lab test. What we need in estimating the final speed of a 5G network is a practical field test. Back in October 2015, one such test conducted by China's Huawei and Japan's NTT Docomo network, they had managed to hit peak data speeds of 3.6 Gbps using a sub 6 GHz band. Singapore, with the average speed of 37 Mbps, is the fastest internet service provider in the world. South Korea has the best LTE coverage, while Canada's network is able to provide speeds up to 40 Mbps. Compare that to the 300 Mbps currently offered by EE's LTE network, you'll see that we are talking about a 12-fold speed increase over 4G here. Suggested 5G wireless performance are network capacity up to 10,000 times capacity of current network, peak data rates of 10 Gbps, cell edge data rates 100 Mbps, latency less than a meter second. Low latency means not only download and upload speeds will be faster, but the response time for starting those data transfer will be similarly snappy. There will be less of a pause between pressing play button and that crisp 4K content starting to stream on your phone. It's not just your phone and your computer anymore. Home appliances, doorbells, security cameras, cars, wearables, dog collars, and so many other inert devices are beginning to connect to the web. Prediction shows that 20.8 billion devices will be connected to the internet by 2020. By comparison, there are currently an estimated 6.4 billion connected devices in the world. That's a lot more devices asking for a quick connection. Rather than faster peak internet connection speeds, 5G planning aims at higher capacity than current 4G, allowing higher number of mobile broadband users per area unit and allowing consumption of higher or unlimited data quantities in gigabyte per month, aiming at lower cost, lower battery consumption and lower latency than 4G equipment. Carriers, chip makers, OEMs and OSATs have been preparing for this next generation 5G wireless standard, as mobile systems and base stations will require new and faster application processors, baseband, and RF devices. Millimeter wave technology for 5G frequencies of above 50 GHz are being considered, and this will present some real challenges in terms of circuit design, the technology, and also the way system is used, as these frequencies do not travel as far and are absorbed almost completely by obstacles. Dense networks, reducing the size of cells, provide a much more overall effective use of the available spectrum. Persuasive networks. This technology being considered for 5G cellular system is where a user can concurrently be connected to several wireless access technologies and seamlessly move between them. Conjugative radio technology. Using the tech, devices will choose the optimum radio access network, modulation scheme, and other parameters to configure itself to gain the best connection and optimum performance. Smart antennas. Using these, it will be possible to alter the beam direction to enable more direct communications and limit interference and increase overall cell capacity. You can always trust Google to come up with filthy alternatives to current thinking. Company's project Skybender has yielded some interesting results in New Mexico. Google is employing drones to transmit high-frequency millimeter waves, which could potentially offer speeds of 40 times that of today's 4G LTE networks. 5G will make it easier for people to download and upload ultra-high definition and 3D videos. It will also make room for thousands of internet-connecting devices entering our everyday world. Just imagine upgrading your data connection from a garden hose to a fire hose. The difference will be notable. With more and more people and devices set to connect it over the next 5 years or so, 5G will likely be the network that has to handle the dawn of the driverless cars. For 5G technology to be able to achieve this, new methods of connecting will be required, as one of the main drawbacks with previous generation is lack of coverage, drop calls, and low performance at cell edges. 5G technology will need to address this. The main downside, other than the prospect of relying on a bunch of flying automated machines, is that the transmission range for millimeter waves is about a tenth of 4G. Also, millimeter wave frequencies don't pass through solid objects very well, which would prove a problem for indoor and urban reception. First of all, we need some global standards to be accepted by international organizations. Most estimates point to a 2020 initial rollout for 5G network technologies. Huawei, for its part, wants to develop a workable 5G standard by 2018, though of course, that doesn't necessarily mean a rollout will occur at that same time. Hopefully, we'll at least have a consistent 4G network by then. Hit that like button if you liked my video, share, and don't forget to comment down below in the comment section. Make sure you subscribe to my channel. Thank you for watching my video.